A Parkinson's diagnosis almost immediately centers on the standard pharmaceutical playbook: levodopa, dopamine agonists, and MAO-B inhibitors. They are the absolute gold standard for managing the most visible motor symptoms of the disease. But prescription medications only address part of the equation. They are designed to suppress symptoms, meaning they do not halt the underlying cellular damage, and they frequently leave a wide range of non-motor symptoms entirely unaddressed. This graph from a Phase 3 clinical trial report shows why we have to separate rigorous science from internet hype. For a decade, supplements like CoQ10 and creatine were heavily promoted to patients. The data proves they flatline. They do not actually slow the progression of the disease. That leaves a critical gap in care. We have to look at the margins, the specific biological vulnerabilities left exposed by standard prescriptions, and find ways to actively protect the neurons you have left. Fighting Parkinson's requires moving beyond baseline symptom management. We can use precise, evidence-based compounds to deliberately engineer a neuroprotective environment in the brain. The first step is addressing the collateral damage of the medications themselves. Long-term use of standard synthetic levodopa therapy actively depletes a body's natural stores of vitamin B12. This flowchart illustrates the cascading effect. As levodopa drives your B12 levels down, it triggers a sharp corresponding spike in a compound called homocysteine. That buildup directly attacks your nerve endings, leading to peripheral neuropathy, a dangerous numbness in the hands and feet. We also have to fortify the body's physical structure. A vast majority of Parkinson's patients are deficient in vitamin D3. Restoring those levels is required to maintain bone density and mitigate severe fall risks. And clinical data even correlates higher serum levels of vitamin D with a reduction in overall disease severity. Looking at the cellular level, we see another vulnerability standard prescriptions miss. This cellular view shows alpha-synuclein, a protein that violently clumps together into toxic blocks inside the neural space, driving the intense neuroinflammation characteristic of the disease. By introducing specific anti-inflammatories like curcumin and omega-3 fatty acids, we can physically intervene. In animal models, these compounds successfully cross the blood-brain barrier to interrupt and dissolve those toxic protein blocks before they can fully form. These specific vitamins and anti-inflammatories pull double duty. They repair the physiological damage caused by your prescriptions, and they fight the internal mechanics of the disease itself. They are required daily maintenance. For managing actual motor fluctuations naturally, we can look to a rigorously studied botanical source, Mucuna pruriens, or the velvet bean. The seeds of this plant naturally contain up to 6% organic levodopa. This comparative timeline graph shows the difference in delivery. Unlike the erratic, sharp spikes typical of synthetic L-dopa, organic levodopa from the velvet bean crosses the biological barrier in a stable, rolling wave. That smooth delivery provides rapid motor relief and frequently results in fewer involuntary, erratic movements known as dyskinesias. Because velvet bean contains authentic levodopa, it interacts directly with your current pharmaceutical prescriptions. Furthermore, commercial over-the-counter supplements vary wildly in their quality control, meaning you risk taking highly inaccurate doses. While botanical L-dopa is an incredibly effective tool for stabilizing motor symptoms, its potency demands respect. It should only be deployed under the strict, ongoing supervision of a movement disorder specialist. Standard pharmaceutical prescriptions have another major limitation. They almost completely bypass the non-motor symptoms of Parkinson's, leaving patients to navigate brain fog, mood dysregulation, and cognitive decline on their own. To address this cognitive frontier, neurology is looking closely at medicinal mushrooms, specifically Hericium erinaceus, better known as lion's mane. Lion's mane contains a unique class of bioactive compounds called erinacines. They are critical because they are physically small enough to naturally cross the blood-brain barrier. Once inside, this diagram illustrates their mechanism of action. The erinacine molecules bind directly to damaged neurons, stimulating the brain to synthesize nerve growth factor and brain-derived neurotropic factor. This instantly triggers the outward growth of new, healthy dendritic branches. Lion's mane doesn't cure motor symptoms, but by actively promoting the repair of your existing neural networks, It acts as a formidable biological ally against the disease's systemic cognitive decline. There is no single magic pill to stop Parkinson's disease, and no complete cure is currently on the market. But you are not powerless. By deploying B vitamins for nerve protection, curcumin for inflammation, lion's mane for cognitive support, and velvet bean for motor management, you actively change the internal environment of your brain. The definitive rule of complementary neurology is integration. These compounds are strict reinforcements. They are designed to work alongside your standard pharmaceutical care, never to replace it. Your immediate next steps are highly practical. Consult directly with your neurologist. Run lab work to measure your baseline blood levels and determine the accurate dosages for your specific biology. When you bridge the specific gaps in standard medicine with rigorous, science-backed compounds, you stop being a passive recipient of care. You take active command over the trajectory of your treatment journey.